up, everyone? Welcome back to another video. In this video we're going to be learning about topic 10.6. In this topic we're going to be learning about 3 different types of line interactions on circles, and in every type there's going to be a different formula. So we're going to be doing some practice problems. Okay, so as you can see, type 1, this happens when we have 2 chords intersecting. So when we have 2 chords intersect, we have 2 parts on each segment of a chord. So the formula we use is part times part equals part times part. And the part we want to use are the parts that are on the same chord. So I would do this part times this part equals this part times this part. And you'll understand if you don't understand. You'll understand more once we do some example problems. In type 2, we have 2 secant lines. And so when we do this, we use the formula outside times whole equals outside times whole. And outside is referring to this outside portion of the secant line. And the whole is the whole secant line. Alright, so you want to do the outside portion times the whole secant line. In type 3, is where we have a tangent line, and that is intersected with a secant line. So in this type, we want to square the tangent and then do what we did in the previous type, which is outside times whole. So we're going to be doing some practice problems. Alright, so this example is type 1, and so the formula that we use is part times part equals part times part. And so remember, we want to use the parts that are on the same chord. So we would do 5 times 20 equals 8 times x, which is 8x. Alright, and so this is pretty straightforward. And so we have 100 equals 8x. And then once we divide by 8, we have 12.5 equals x. So when we have integers like this, it's going to be really easy, but when we have expressions, it's going to be a little bit trickier, as in the next example. So as you can see, we have a lot of variables and expressions, and so we use the same formula, part times part equals part times part. So we would do x times x plus 4, because these are on the same chord, and that's going to be equal to the other parts on the other chord, which is x plus 1 times x plus 2. And from here is just algebra, simplify the equation. So we have x squared plus 4x. I'm just distributing right here. Then here you can use the box method, or you can use the trick. So we have x squared plus 2x plus 2. And here the x's cancel out, and so all we have to do is subtract by 2x. So we have 2x over here, that's equal to 2, divided by 2, x equals 1. So like I said, expressions are going to be a little more trickier, more work, but if you use the formula and do the math correctly, it's not that hard. And so hopefully this type, the type 1, where we have 2 chords, that's one of the easiest ones, so hopefully this makes sense. And so we're going to move on to type 2. Alright, type 2, the formula outside times whole equals outside times whole. Alright, so we would take, in this example, we would take the outside, which is 5, times the whole, which is 9. So remember, we have to have the whole thing. So 5 plus 4 is 9. So we have 5 times 9 equals outside 3, and it's not 3x. This is and the whole is not 3x. It's actually 3 plus x. So you're not multiplying right here. You have to add them, because we have 3, and this is 3 plus x, because we don't know what this value is right here. So we just put that in our parentheses. And so from here, we can multiply. So we have 45 equals 9 plus 3x, subtract 9, we have 36 equals 3x, and then divide by 3, 12 equals x. And so that's our answer. So the really important part about this is making sure you have the right equation when you have a variable in your secant, yeah. So make sure you put 3 plus x and not 3x. Okay, so in the next problem, so yeah, same scenario. We have outside times whole equals outside times whole. So we have 4 times, yeah, so like when I said expressions are going to make it a lot more complicated. So this would be 4 times 4 plus x minus 7. We have to figure out the whole of the line, and we don't know what x is right now, so we have to do this. And so same thing for the other secant. We have 3 times 3 plus x minus 4, because that is the whole. And then from here we can use distributive property. So we have 16 plus 4x minus 28 equals 9 plus 3x minus 12. And then from here we can just combine like terms on both sides. So on here we would have 4x minus 12 equals 3x minus 3. Subtract 3x, we have x minus 12 equals negative 3, add 12, x equals 9. So yeah, expressions make it way more harder, but once you understand like the formula and everything, it shouldn't be that hard. And hopefully type 2 of circles, when we have 2 secants, hopefully this made sense as well. And so we're going to move on to the final part, type 3. So type 3, this is when we have a tangent and a secant. And so the formula is tangent squared equals part times whole. And so our tangent in this case is x. So we do x squared equals outside, which is 5, because if the whole thing's 20 and the inside part is 15, that means the outside part has to be 5. So 5 times the whole, which is 20. And so x squared equals 100, and then the square root of 100 is 10. And so, boom. And this is probably going to be like one of the easier questions if you have a problem with tangent secant. So yeah. And then our last problem of the video. And so same scenario, same formula. Tangent squared, so our tangent in this case is 12. So 12 squared, 144, equals equals outside times whole. So the outside is 10, and the whole, just like the last type, you gotta do 10 plus x, because that is the whole. 10x is not the whole, 10 plus x is. And so here, 144 stays the same. Distributive property on the right side, 100 plus 10x. Subtract 100, so we have 44 equals 10x. And so divide by 10, x equals 4.4. So once you understand like the gist and everything about all 3 of these types of circles, it's not going to be that hard. So if you have any questions about this, you can always tell me, and hopefully I can like clarify it. And so that's going to end off today's video, and yeah, have a good day.